our studies.
So, as we already said, we bring direct manipulation onto the floor, and how the name says manipulation is not hands. So, what means direct manipulation with feet? For that, we conducted a few studies, and please notice the studies are not scientific, so we tested no hypothesis. It was just to inform our design. Okay, the first question was, how can we create a passive tracking state? That means, how can we walk over the floor without setting things off? As we mentioned earlier, we want to distinguish between different gates, and there are a lot of gates. We want to take some which are discoverable and ergonomic. For that, we conducted our first study. So, the users should walk over two buttons, and while they not activate the cancel button, but activate the OK button. And that was how it looks like. He is dwelling on the button. The next one is jumping on it. He is stomping on it. And the last one is tapping on it. So not all of these ideas are equally plausible. Because, for example, dwelling means that you can never stop if you don't want to activate something. The most popular answer was actually to tap on the button you want to activate. And that's what we tried out. So I'm going to show you a short demo where somebody is painting and somebody other is walking over it without interfering. So he's walking over. Yeah. Okay. And the system sees this picture. So you see here somebody walking. And after this, somebody is tapping. And it's quite different. So it's really easy to distinguish between these two gates. Okay, and this gate recognition is only possible because we use FTIR. So now that we know when users activate, it's important to know what are they actually interacting with. For example, here are 3 buttons. So which one do users expect to be pressed? We asked the user to paint all buttons red, which should be pressed, and only 2 really thought about the contact area, so they eroded these small hexagons on the arc from the shoe. The most people only thought about the projection of the shoe, and some excluded some on the outside. Just another threshold in this way. Okay, so what we learned was, for the most people, it's not the contact area, but projection. This is one thing where actually frontier eye would be easier because frontier eye is all about projection, but with FTIR we can reconstruct the complete shoe print. Okay, so if we go with the projection model, that means that the interface will become very huge because we have huge buttons. But we wanted to have 10,000 objects, and that means we want to have large buttons. So you know that from the tabletop that the hand is already reduced to a single hotspot. And we were wondering if we can use that with feet. To validate this, we conducted another short study where people should type on 3 different sizes of keyboard, and this is actually the large one. Notice please that this is still quite smaller than the wall of the foot. Then we added a medium one, which was 50% smaller, and just out of curiosity we added a really small one. The keys are actually smaller than these of a regular QWERTY keyboard. So here is somebody typing on the medium keyboard, and you can see the hotspot from under it, the red one. Okay, on the medium keyboard it was less than 10% of error rate, and on the large one it was less than 3%. And the question question now is, how big should we build a floor that we can fit 10,000 objects? And if we take these 3 by 4 centimeter objects, it would be a 3 by 4 meter floor. That sounds insanely large, but actually we're building such a floor right now. Okay, so because of FTIR, again, we can lock the hotspot to a specific position on the floor. We are still interacting with many objects because this hotspot model was under the assumption that users agree on where the hotspot is. Do they really? So we conducted a small study where users should step on a crosshair, and we found out that they disagree pretty massively. So if we just take a fixed hotspot, that would mean that we would be really inaccurate. So we thought that every user pick their own hotspot. And then in Multitoe, that looks like this. Here's the hotspot. Okay, but that comes with a side effect for personalized hotspot. You need to recognize the user, like here. Okay, and again, only because of FTIR it's possible to personalize, because we can recognize the user by their shoe sole. Okay, so the last one for large floors is we have to think about distances and menus. So how can we avoid long distances? We don't take stationary menus, we take localized menus, and how can we invoke them? Based on a short study, we decided to invoke them by jumping. Okay, and again, with FTIR, it's pretty easy to distinguish between contact and no contact while jumping. So, these 4 things together enable direct manipulation, and in our case, FTIR is the key.
So, let's quickly go through some of the algorithms that we use. For soul recognition, we currently use FTIR and from the eye combined. And we first use from the eye to find out where the shoe actually is. And then we threshold out the FTIR part and use that for user identification. So we go into our database and look for matches based on the center points of the blobs. But this doesn't really work very well for many users right now. So we're trying to find a technology that works better. For example, we're experimenting right now with fingerprinting using the frequency domain of the images. So, yeah. There's a couple of other things that we stumbled upon the way. We found that we can enable more degrees of freedom, for example, like this. Here you can see like how the person strays to the side and fires. And we also can do head tracking or approximate head tracking with that. And this works like that. And this is a tribute to Johnny Lee. Okay, so that's how it works. So that got us thinking, and we were wondering what else we can do, like what else can we infer about the space or about what is happening above the floor. And so we are currently investigating how we can like help smart rooms and how we can find out what is happening above the surface. The prototype that we're currently building, this is a schematic of it, and this is the real thing. This is the very early building. It's much more advanced right now, and we're currently testing the glass that we use for structural support, but it's not quite finished yet. So, to summarize, we ported direct visualization to the floor to allow manipulations of tens of thousands of objects. And we found that gravity kind of comes in the way, but we solved that by using FTIR to reintroduce a second state. I'd also like to thank the rest of our team, our undergraduate team, Thomas, Dorian, and Rene, as well as Christian Holz, Torsten, Becker, and our advisor, Baudisch.